Greetings! This recording covers the lesson on measures of dispersion. Knowing the center of the data is valuable. However, understanding the spread of the data would provide us additional consideration in our decisions. For example, you went to a certain beach resort for a sea swimming. There is that area in which the mean level of water is at 4 feet. Since you are 5 feet and 3 inches tall, you may feel safe to stay in that area. But what about if you were informed that the level varies from a foot to 7 feet? Will you be complacent? At the end of this lesson, you must have computed for the dispersion of the data. Measure of dispersion is also referred to as measure of variation because it measures the variability or spread of the data. A small value for a measure of dispersion means that the data are clustered closely around the arithmetic mean. It implies that the mean is considered representative of the data. Conversely, a large value depicts an unreliable mean since data are widely spread. In this lesson, we will consider only 4 measures of dispersion involving ungrouped data. These are the range, mean absolute deviation, variance, and standard deviation. The easiest one to compute is the range. It is simply the difference between the largest and the lowest value in a data set. The formula is the same whether of the population or from a sample. To reiterate, in calculating for the range, only 2 values are used, the highest and the lowest. This measure of dispersion is influenced by extreme values. Range is easy to compute and understand. At this time, let me show you how to compute for the range in MS Excel. Please take note that there is also a range term used in MS Excel which refers to a number of cells desired to be selected. But our aim here is to compute for the range as we used in statistics. So to do that, we're going to make use of the built-in functions. So I'm going to start with typing equal sign to the desired cell where I intend to display the result. Then we make use of the function max to determine the highest value from the data set. So the data set there is the range being referred to in MS Excel, minus another function mean to determine the lowest value from a range in MS Excel, which in statistics refer it to the data set. Then press enter key. So the result is 4. So if by observation we're going to look for the highest value is 11 and the lowest value is 7, the difference between 11 and 7 is indeed 4. Another measure of variation, but is not commonly used, is the mean absolute deviation. It is the sum of the absolute deviations from the mean divided by the number of observations. The same formula is used whether data set is of the population or from a sample only. Mean absolute deviation is reasonably influenced by large or small values. In calculating it, all values are used. However, the absolute values are somewhat difficult to work with. At this time, let me show you on how to compute for the mean absolute deviation in MS Excel. Using the same data set, the first thing that we're going to do is to compute for the mean. The mean of this data set is computed by making use of the average function in MS Excel. The result is 9. Next to that is to determine the absolute deviation. To do that, we make use of another function, the abs, to determine the absolute value. Enclosed to that is the difference between this data and the mean. Since the mean will be used to each of the data, so we're going to make use of the absolute referencing function by pressing F4. Then we enclose it and then press the enter key. We're just going to copy the formula here. So by copying the formula with the absolute reference, this one means the absolute difference between this and the mean. This one means the absolute difference between this data and the mean, and so on. Next to that is we're going to copy this formula to determine the mean of these absolute deviations. It results to 1.142857143, but if we wish to display only 2 decimal places, then we're going to make use of another function, round, and we're going to limit it into 2 decimal places only. So that results to a mean absolute deviation of 1.14. Next is the variance. It is the mean of the squared deviations from the arithmetic mean. Different formula is used for a data set of the population and a data set from a sample. For the population, the formula is denoted by the squared lowercase sigma, which is equal to the sum of the squared deviations from the arithmetic mean divided by the population size. Please be reminded that the uppercase sigma represents the summation. While for the sample, it is denoted by the square of lowercase s, which is equal to the sum of the deviations from the arithmetic mean divided by less 1 of the sample size. The difference in the formula is the divisor. In calculating variance, all observations are used. It is reasonably influenced by extreme observations. Its unit of measurement is the square unit of the original data. At this time, let me show you on how to compute for the variance in MS Excel. Please be reminded that we have different formula to compute for a variance from a data set of a population and a different formula if the data set is coming from a sample only. So for the population variance, we make use of the function var.p. Then we enclose this data set. Press enter key. While for the sample, that is var.s, the same data set, and it results to this one. So you will notice that the sample variance is greater than the population variance because the divisor of the sample variance is lower than the divisor for the formula we use in determining the variance of a population. Again, if you want to display the result into decimal places, so we're just going to add the round function. Lastly, which is the most frequently and favorably used one, is the standard deviation. It is the square root of the average squared distance from the mean. Different formula is used for a data set of the population and a data set from a sample. For the population, the formula is denoted by the lowercase sigma, which is equal to the square root of the sum of the square deviations from the arithmetic mean divided by the population size. While for the sample, it is denoted by the lowercase s, which is equal to the square root of the sum of the deviations from the arithmetic mean divided by less 1 of the sample size. The difference between the formulas is the divisor. Standard deviation is simply the square root of the variance. Its unit of measurement is the same as the unit of the original data. It cannot be negative. And as mentioned previously, it is the most widely reported measure of dispersion. At this time, let me show you on how to compute for the standard deviation in MS Excel. Again, we also have different formulas for the population and the sample. The difference is their divisor. So for the population, we make use of stdev function stdev.p function for the population involving population dataset. While for the sample, we make use of the stdev.s. So it is a standard deviation from a sample dataset. You will notice that again, the standard deviation of the sample is higher than that of the population because the divisor in the standard deviation of a sample is smaller than that of the population. So to display this into decimal places, again, just put the round, include the round function. It's 1.31 while the other one is 1.41. This marks the end of our lesson on measures of dispersion.